So let's now continue and make sure that the computer also makes a choice. So for that, we can add a new function here, get computer choice, an anonymous function stored in this constant here. And there I want to calculate a random number between 0 and 1. And if it's between 0 and .33, let's say that's rock. If it's between .34 and .67, it's scissors, and so on. So that a third of that range is reserved for every choice. So we can get the random value here, store it in a constant of any name of your choice. With moth random, we haven't really used that before. Moth is a globally available object, you could say, made available by the browser in JavaScript. And it has a random method which generates a random number between 0 and 1. Now we can add an if check here and see if the random value is, let's say, smaller than .34. In that case, let's say the choice is rock. So here we can return rock. And since we return, this function will then stop at this point, of course. Else if, let's say the random value is smaller than .67, which we only reach if this was false. So this will not kick in for a value like 0.2, because of course that would be true for that value, but so is this. And since we handle this true value here already, this other else if block will not kick in, no matter if we return here or not. So if we are greater than .34 but smaller than 6.7, I return paper. And last but not least, if neither is the case, so for all other cases, so for any value above .67, I return scissors. So that's how the computer chooses a value. It's simply a random choice, does not take into account what we chose, because of course, like in real life, we want to choose simultaneously without knowing what the other party chose. And therefore now here, we can store the computer choice here in a constant by calling get computer choice. So now we have both choices stored. Now it's time to find out who won. And for that, I'll add yet another function, which I'll name determine winner or get winner, however you want to call it. And this function, this function should now actually take some arguments. It takes the computer choice, I'll name it C choice here, and the player choice as arguments. And then we just need a if check where we go through the different combinations we have. Now the first combination we have is that the computer choice is equal to the player choice, in which case we have a draw, right? So I want to return draw here, and just as before, if I use string identifiers, I want to use a global constant for that to rule out typos. So here I'll add a result draw constant, which includes that draw value. Then here a result player wins constant, where I maybe store player wins as an identifier. And then result computer wins, where we store computer wins as an identifier. The exact values for these identifiers, of course, are totally up to you. So now with that here, I want to return result draw in the end. Now else if, so if we don't have a draw, we want to find out if the player or the computer won. So here we want to check if, let's say the computer choice is equal to rock and the player choice is equal to, let's say, paper. Then we know the player won, right? Because player chose paper, paper beats rock. So in this case, the player would have won. But of course, that's not the only combination. So we need to add another block, and we can do so by adding the OR operator. Thanks to precedence, this is combined together and then compared to whatever we have after OR. This is exactly what we want, because these two belong together. So that's one possible win condition. If this yields true, then the player won. Another possible win condition is that the computer chose, let's say, paper, and the player chose scissors. Then the player won as well. So here I want to group together all the conditions where the player wins. Let me add the if body thereafter, so the curly braces, and use the auto formatting shortcut to auto format this. Now this also added some parentheses here to make this easier to read. Technically, they're not required. You can add them and auto formatting will re-add them, but you don't need them here because of precedence. Just want to highlight this again. So let's add the last combination here, and that's that the computer chose scissors and the player chose rock. In this case, we also won, right? So in all these cases, we won, and therefore here we can return result player wins. Else, we know that the computer won, so we can return result computer wins. So that's now our getWinner function, and now we can call that down there in our anonymous function, which we call when we start the game. I add a winner variable or constant here since we never assign a new value. And we can call getWinner here and forward the computer choice as a first argument and the player selection, or to be in line, we can also name this here player choice, of course, doesn't matter, as a second argument. So this will give us the winner, and for now, I'll just log winner here. Of course, that's not the final output to see whether that works. So let's save all of that and reload here, start a game, and now let's choose paper, and looks like we won. Now we don't really see what the computer chose, but we won. That's good, right? So yeah, we'll probably find out what the computer chose later, once we add more code. So let's reload, because right now we can't restart the game in any other way. So let's reload, and let's maybe go for scissors. And looks like the computer also chose that. Well, let's also see if we can lose if I choose rock. Well, computer also chose that. Let's go for rock again. Wow. Computer won now. So, looks like the computer chose paper. So that works. Of course, we don't really have the best possible output because we don't really see what the computer chose, but we'll get there. Before we get there, though, let's take a step back and learn more about functions and a different way of creating functions.